So now we're going to do the composition of a function, but in part 2 we're going to make it just a little bit more complicated. So here we have f of x equals 2x squared plus 3x plus 1, so it's a second degree function, and g of x equals x plus 1, so it's a linear function, a first degree function. And let's see what happens if we compose the function f with the function g. So we have f composed of g. So what that means is we're going to make the function f out of the function g. In fact, what it means is I can replace all the variables inside f by the function g of x. So what that means is my x here and my x here will be replaced by everything here. What that looks like is 2 times bracket x plus 1 squared plus 3 times x plus 1 plus 1. So notice that everywhere where there was an x in my f, I've now replaced it by a pair of brackets, and inside my brackets I've stuck the function g of x, which happens to be x plus 1. So once I've done that, I just expand everything and then simplify as much as possible. So what I have is really just 2 times x plus 1 times x plus 1 plus 3 times x plus 1 plus 1. Foiling over here, like this, I get 2 times x squared plus 2x plus 1 plus, and then distributing the 3 over here, 3x plus 3 plus 1. Now distributing the 2 that's in front here everywhere, I get 2x squared plus 2x plus 4x plus 2 plus, I copy the 3x plus 3 plus 1, 3x plus 3 plus 1. Now I can group all the common or similar terms. There's no similar term that has an x squared in it, so that stays as it is. So I have equals 2x squared. And then I notice that there's a 4x, which is common, and that has a common term with 3x. And then the 2, the 3, and the 1 are similar terms, so I can group them together as well. So starting with the 4x plus 3x, I get plus 7x. And then 2 plus 3 plus 1 is plus 6. So after composing f with g, I get 2x squared plus 7x plus 6. I'll leave it as an exercise to you guys to find out what happens if I compose g with a function f. What does that give me? Now remember, it's not the same thing as f composed of g, not necessarily. So you actually have to do this and see what it gives you. In this case here, a little hint, in this case here, you would take the function f and you would stick it inside the function g. You would do g composed of f of x. So inside my g I would have f of x. So I leave that to you guys as an exercise.